All right, so we are now going to start topic 1 by talking a little bit about graphs. We spent a lot of time talking specifically about solving equations, which we will continue to do in this section, but I want to look at it from the perspective of a function that has been graphed, specifically a quadratic function that has been graphed. So take a look at these 3 examples of quadratic functions graphed on a coordinate plane. And I'm going to introduce a new vocabulary term that, if I haven't mentioned it in class already, officially I want you to write in your notes the term root of an equation. Root, like you see written here, R-O-O-T. It really is just the x-intercepts. It's another word for the x-intercepts. But we call them the roots of the equation because they kind of ground the function. It's like the points that attach it to the x-axis. And as we learned in lesson 3, those points can be really helpful in drawing a basic graph. So we see 3 different examples of quadratic functions. First, we have 2 roots. That's where the parabola comes and passes down through and across the x-axis, turns around and comes back and passes through again. So 2 roots, 2 places where we have x-intercepts or where the graph is kind of attached to the x-axis. The second example is an example of something with 1 root. It's what would happen if you have a parabola that comes and just barely touches where the vertex is on the axis, the x-axis, and then turns around and goes back. So it doesn't ever cross, but it kind of comes down and bounces off and goes back up. So that would be 1 root. And then we have the possibility of a quadratic that has no roots. So if this parabola is up here above the x-axis, or the other option would be if it was a negative parabola and was down below the x-axis, either way we can have we see that we can have quadratics, parabolas that will never have x-intercepts, and so that would be called a quadratic with no roots, or later we'll learn that there's a term called imaginary roots. We can define those a little bit better. As of right now, we're just going to say no roots. There are no real roots to this equation. Now, the other thing that we can call these instead of roots is we can call them zeros. So we could say this is an equation with 2 zeros, or 1 0, or no zeros. The term zeros means exactly the same as the term roots, and that should make sense. Why? Because these points are where the whole equation equals 0. So looking at this is kind of my standard y equals ax squared plus bx plus c. I could put any numbers in for a, b, and c, and as long as a isn't 0, right, because we need to have an x squared term to call it a quadratic. As long as a isn't 0, we can put any number in here, and what we would have is a quadratic function. When this quadratic function has a y value of 0, that's where we find these roots. So that's why we use the term root or 0 interchangeably. All right, so we have our 3 examples of different types of equations, roots or zeros, and we have been talking about different ways to figure out where those points are. Specifically, we learned that we could make the whole equation equal 0, and we could try to put it into factored form and figure out what those points are. We also talked about the possibility of using completing the square method, which ends up putting it into a form of some number over here equals like a perfect square. And we were able to use that to solve as well. The problem that you may have noticed, well, there's no real problem, except for the fact that it takes a lot of time to solve these equations. And every time, we kind of are going through the same procedure over and over and over again with different numbers, but we're doing the same work over and over and over again. And maybe somewhere along the way, you might have thought, isn't there an easier way to do this? If we're doing it the same way every time, why can't we just come up with like a formula that gives us the answer? And believe it or not, that formula does exist. And you may or may not have heard of it before, but it's called the quadratic formula. And this is what it is. If I have an equation ax squared plus bx plus c, any quadratic with coefficients a and b and some number c for a constant term. And I want to know when that quadratic expression is equal to 0. I can figure it out by saying at any point where x is equal to negative b, so that's coming from here, actually I'm going to just box this off so it doesn't look like this is not part of the equation. This is just our basic. Negative b plus or minus the square root of b squared minus 4ac all over 2a. That's it. Kind of crazy. If you've never seen it before, it probably looks like a lot of numbers. But this formula will give me the zeros or the roots of any quadratic equation, no matter what kind of equation it is, without having to go through any other steps except just plugging the numbers in where b, a, and c are, putting it into your calculator, and getting an answer. Or even better, you don't even have to plug it into your calculator. You can just leave it in square root form if you want to. That's it. It's a beautiful, beautiful thing, the quadratic formula. Now, as it turns out, the quadratic formula didn't just come out of nowhere. Somebody figured it out using some of the techniques that we've already learned in class. And I think I'm going to save that, what we call a proof, that proof of the quadratic formula for class time, because I think it'll be a little more fun than just watching me do it here on the screen. But the bottom line is this. Factoring is really helpful. It can be really fast. If you learn how to do it quickly, you can see how to factor simple expressions once you get the hang of it in a very quick way with very simple computations. But it doesn't work for all of the equations. We can use completing the square for any quadratic equation, but it kind of takes a long time. So now we have the quadratic formula, which now can be used for any equation at any time, any quadratic equation to solve for the zeros. In the next topic video, we're going to look at how we actually use this formula. So make sure you write it in your notes so that you have it on hand to be looking at. As an FYI, you want to make sure you memorize this formula. This is like one of those you absolutely have to memorize it to pass Algebra 2. So start saying it over and over and over again. Say it in your sleep. Sing it to yourself, whatever you need to do. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Don't forget it. All right, that's it for now, and we'll pick up with the rest in topic 2.